Hi, I am Goonmeet Bajaj and I will be presenting our work titled Understanding Knowledge Gaps in Visual Understanding, Implications for Gap Identification and Testing. Humans have the cognitive ability to deal with missing information or incomplete tasks. We are able to identify such situations and can navigate our environment to resolve gaps in our knowledge. For example, if we encounter an unknown word, we know to look this word up in a dictionary and understand its meaning. However, AI agents are not always able to handle such gaps in their knowledge. Therefore, we aim to create a framework in which AI agents can identify and resolve their knowledge gaps. To learn how to create such a framework, we use visual question answering, or VQA tasks, as a proxy to understand machine cognition. VQA sits at a challenging intersection of three areas of AI: vision, reasoning, and language. There have been many advances in this field and a plethora of datasets have been released. However, researchers have started to take note that current VQA agents, or models, are often focused on language prior and statistical biases. Informally, a knowledge gap is an instance of limited information or capabilities that leads to an agent being inefficient or incapable of completing a given task. In the VQA setting, knowledge gaps can occur when an agent or a human cannot answer a question corresponding to a presented image. For example, in the first question, the agent might not know what tropical birds are, but knows that there are parrots present in the image. This failure can occur for a variety of reasons, including, but not limited to, missing information, lack of reasoning skills, or an incorrectly posed question. We apply the presented taxonomy to the 2019 Stanford GQA dataset. This dataset contains a rich set of annotations that we use to identify knowledge gaps for each question. In this work, we focus on all knowledge gaps in bold. The extended version of our paper is available on arXiv and focuses on all knowledge gaps in green. Our paper contains a detailed definition of the knowledge gaps in green and the mapping process to tag questions with their respective knowledge gaps. Additionally, the definition of all knowledge gaps in the taxonomy can be found in my collaborator Daniel's master's thesis. Here we present sample question and image pairs from the dataset along with the knowledge gaps we tag the questions with. For example, in image B, the question asks, which are less healthy, the brownies or the cherries? We tag this question with a reasoning gap, as the question requires external knowledge to arrive at the correct answer. In other words, we cannot just answer the question by merely looking at the image. After tagging questions with their respective knowledge gaps using our rule-based mapping process, we observed a skew in the distribution for the number of questions per knowledge gap. The GQA dataset primarily contains more questions that inquire about an object's attribute, material composition, or the spatial relationship among objects. This skew inspires us to use a question generation strategy to generate questions for those knowledge gaps that do not have a high volume of questions. We use a sequence-to-sequence approach to generate new questions. We closely follow a recent work that generates question templates using knowledge graph triples. Similarly, we train our model using paths from an image's scene graph. The encoder encodes paths along a scene graph, and the decoder uses the learned representation to generate new question templates. These question templates are later populated with data from the input path to create a new question. The table provides sample questions for each knowledge gap and the question template that is used during training. Here we present the results of one of our question generation models. We provide one example from our test set. We share the input triple and the generated and populated templates. The table presents the results of our question generation model in terms of their BLEU and METEOR scores. These are commonly used metrics used to evaluate natural language generation frameworks. We also share the number of novel question templates we are able to generate that do not exist in the training data. This work is an initial step towards understanding how to build a framework for automatic knowledge gap identification and resolution. We focus on investigating knowledge gaps that can occur in the VQA setting. Additionally, we observed a skew in the number of questions per knowledge gap. We then specifically generate new questions for those knowledge gaps that lack a high volume of questions. In the future, we aim to expand our current work to provide answers for the generated questions, improve our question generation model, simulate more knowledge gaps, and test our balanced data set. Our next step is also to understand how to automatically identify and resolve these gaps. If you have any questions, comments, feedback, or suggestions, feel free to reach out to our team. Once again, my name is Goonmeet Bajaj, and my email is bajaj.32@osu.edu.